So that is encryption and the decryption procedure. Sender encrypts the message with the receiver's public key, where it is going to provide the but not authentication. Encryption means it is not providing the authentication. And so in order to provide the authentication, so here it uses the digital signature concept, where the sender signs a message. So only some part of the document, so sender will so some part of the message will be encrypted, and that will be considered as the digital signature for the document. And in order to provide the signature, it uses the sender's private key. Sender will use its private key. Whereas in encryption and decryption, sender uses the receiver's public key. If you observe, encryption and decryption, is nothing but which will be used in the symmetric algorithms. In symmetric algorithms, in order to share the key between sender and receiver, again, this asymmetric key algorithms will be used to provide the security to the machine. Okay. So these are the requirements of the algorithm. Like for every public key crypto system, initially some Diffie and Hellman was developed, isn't it? Diffie and Hellman developed this public key crypto system concept. So here the requirements of public key crypto systems will be like sender and receiver will be there, right? So if sender wants to send a message to the receiver, first step is receiver has to communicate the keys. I mean, receiver has to develop the keys. So party B means it is the receiver. Receiver has to generate a key pair. Communication is from the message will be transmitted from sender to the receiver, but receiver has to give its public key to that. Then only sender can send the message, encrypt the message and transmit. So that is why receiver should be generated. One is public and the other one is private key. So public will be represented with KU and private key will be represented with KR. Once it is done, it will be easy for sender, that is knowing the public key. Knowing the public key of receiver, and anyway, sender will have the message, plain text. So using the message and the receiver's public key, sender can generate the ciphertext. So once it is generated, so receiver, what receiver is going to do? Receiver will take the private key of the receiver and the ciphertext and applies the decryption algorithm. So in order to get the plain text. So simply plain text is nothing but, so here this is a ciphertext. So how the ciphertext was generated? Ciphertext is nothing but encryption of plain text using the receiver's public key. Okay, so C is nothing but encryption of message using, so message will be encrypted using the receiver's public key, not the private key, receiver's public key. So this is nothing but the C. So the message will be, the ciphertext will be converted to the plain text by applying the decryption algorithm with receiver's private key. So it is computationally infeasible for an opponent, that is the cryptanalyst. So cryptanalyst will have idea about what cryptanalyst will have the public key of the receiver and also the algorithm, encryption algorithm. But in order to perform the decryption, it requires what? So decryption requires receiver's private key, isn't it? Receiver's private key and the ciphertext. Yes, opponent knows the public key, encryption algorithm, and the ciphertext, but receiver does not know what is the private key of the receiver. So that is why it is computationally infeasible for opponent knowing the public key, by knowing the public key and to determine the private key. So because public keys are different from the private key, there is no relation between the public and private keys. And also it is computationally infeasible for an opponent knowing the public key and the ciphertext to recover the plain text message, because that to recover the plain text, it requires the private key of the receiver. And so here, so as I said, these public key crypto systems, among the public and private keys, if one is used as a public key, the other one can be used as a private key. So that is all depends on the sender or the receiver. So sender and receiver will have a set of keys, isn't it? So based on that, whatever the key is shared, that will be considered as a public, the other will be considered as a private. Okay, so here if you observe, so for encryption, first, so in order to get the at receiver side, this is at the receiver side. So receiver is initially receiver is having some ciphertext. So ciphertext, in order to generate the plain text from the ciphertext, what it is going to do is first, it is whatever the plain text is. This is at sender side. KRB, receiver's private key. This is a receiver's private key. So the message is encrypted using the receiver's private, not encryption. This is a decryption. Receiver private key was used, and then the encryption was done by again the receiver's private key. Okay, encryption was done by receiver's private key. So this is the first algorithm. So in your syllabus, you are having two algorithms, public key crypto system algorithms. One is RSA and the other one is Diffie-Hellman. First, we'll go with the RSA algorithm. Yes, any doubts about the introduction part of public key crypto system? No doubts. Okay, all of you answer this poll question. Yes, answer the question. Okay, I'm going to end the poll. Question is, if sender is using receiver's public key for encryption, then authentication will be provided. True or false? Answer is false. Because you see, sender is using receiver's public key means, so anyone will have, everybody will have the receiver's public key. So then how one can say that it is from so and so person? There is no authentication, right? If sender is using sender's if sender is using sender's private key, then the authentication will be provided. One can say that it is from so and so person because the person has used the private key. So if sender is using the receiver's public key means anyone can send the message to the receiver. Okay, because receiver's public keys can be accessed by anyone. Only 2 students. And also responses are only 17 students responded. Okay. So coming to the algorithm which we are going to use, the public key crypto system algorithms are. So first algorithm is RSA. So it was developed by Ron Rivest. Okay, Ron Rivest, Shamir and Len Edelman. These 3 persons developed the algorithm. So the name was given R. So R from Rivest, S from Shamir and A from Edelman. Combinedly, they have given the name RSA algorithm, and it was developed in MIT University in 1978. Okay. So it is a public key encryption algorithm. RSA is a public key encryption algorithm. And mainly, so this algorithm, how the procedure will be, procedure of RSA is, it uses, as I said, all asymmetric algorithms uses some mathematical functions. Mainly, many of the algorithms uses the prime numbers. Okay, the input values will be considered as a prime numbers. So already we discussed the prime numbers in number theory. Okay, the scheme makes use of an expression with exponential. So how the RSA algorithm uses some plain text. Okay, so anyway, the procedure is, it has to convert the plain text to the ciphertext. So some plain text which is less than n and the ciphertext which is less than n, where n is some number, so which is some modulo n, so it is Cn, okay, which will be in the modular system, that is Zn. Suppose if Z10 is there, a plain text value is less than this value 10. Suppose if Z 50, then a value will be less than 50, that is from 0 to 49. Value will be 0 to 49, like that. Okay, so whatever the values are there, it is going to convert the value into binary. So how the the procedure of RSA is, here initially sender wants to send okay, so, Alice and so if Alice and Bob are there, so Alice will send a message, that is ciphertext. So before going to send the ciphertext, first Bob has to send the key. Okay, Bob has to send the key. Which key? Bob has to give its public key. Okay, Bob has to give the public key. So here it uses two terms like E and D. So here E will be used for the public key and D will be used for the private key. Okay. EB means Bob's public key. So first Bob has to generate two keys, public and the private keys. So that is once it is generated, it has to send its public key to the Alice. Then only Alice can send. Can encrypt the message and can send the ciphertext. So for that, what the Bob is going to do is, at Bob's side, so first Bob will choose some two prime numbers. Bob will take two prime numbers. Bob will choose two prime numbers and then two prime numbers will be taken, like P and Q are the prime numbers. Then the second step is, Bob will calculate the product of these two prime numbers, that is n. N is equals to P into Q. That will be calculated, P into Q. So once it is done, Bob will, third step is, Bob will take, will calculate of n, will calculate phi of n. So what is this phi of n? Phi of n is nothing but p minus 1 into q minus 1, because phi of n is a Euler-Stoichhian function. So if p is a prime number and q is a prime number, okay, so if p and q both are the prime numbers, Euler-Stoichhian function is nothing but it is the numbers, the total number of integers which are relatively prime to n, isn't it? Which are relatively prime to n. So that is why phi of n is equals to p minus 1 into q minus 1. So once it is calculated, this phi of n value, what it is going to do is, it will choose some. So first step is, it will consider two prime numbers, then multiply the two prime numbers. Then third step is calculate phi of n, and fourth step is Bob will choose some value, okay, some number, that is E. So Bob will choose some public key. So public key is a number. So we'll assume some public key E. So so by assuming that, it has to satisfy that E into D is congruently equivalent to 1 mod phi of n, 1 mod phi of n. So it should satisfy this condition. According to that, Bob has to choose some E. Okay, Bob has to choose some E. E is the public key of Bob. And what is D means? D is the private key. So once Bob chooses E, so using this formula, so one can get the value of D. So E into D is equals to 1 mod phi of n. So from that you can get the D. So once E value is chosen by the Bob, so that E can be transmitted to A. That is, the E can be transmitted to the sender, and sender can encrypt the message. So in order to encrypt the message, what the sender will do is, so sender, this M is the message. So sender will apply this formula at encryption side. Sender will apply this formula. That is plaintext power E. E is a value which is chosen by the receiver. That is Bob. E mod N. E mod N. What is N? N is nothing but the product of P and Q. So where M is less than N. So always what are the plain text we are going to choose, the sender is going to send that value is less than the N. According to that plain text will be chosen. Then M power E mod N, whatever the result is there, that will be considered as the ciphertext. Okay, ciphertext. At the receiver side, so what Bob will do? Bob will do the decryption. So this is the second formula is for decryption. So already Bob knows what is the private key, that is D. So E is the public key and D is the private key. So using that private key, and Bob will also have the ciphertext. C is the ciphertext. So C power D mod N, where N is the multiplication of P and Q, two prime numbers. We'll get the plain text. So these two are the formulas. And in order to get these E and D values, first it has to select the two prime numbers. That is the first step. We will see the details about RSA in the next class. Thank you. Any doubts? Okay, we can leave. Thank you.